Welcome back to Swift Fundamentals. Today, we will be looking at control flow and how that allows us to make our code dynamic. Up until this point, our code has been very static with declaring variables, evaluating expressions, and doing math with numbers. But now, we will learn how to make our code respond given a situation. When you think of an application like Spotify, we've come to expect it to respond according to what we do. For example, if we have loop on, and we are listening to an album, then the album will keep playing after the last song. While if it's off, then the album just ends. This is the essence of what control flow aims to do. Let's start by looking at one tool we have to implement this design called an if statement. As an example, let's declare a variable called GamePoints and set that to 500. Now in our make-believe game, we want to do things according to how many game points we have. So let's imagine that at 200 points, you gain an extra life. We start off by writing our keyword if, which lets the computer know that we are starting our statement. Next, we follow it up with some kind of expression as we've seen before that evaluates to a bool. In this case, if the game points is greater than 200 points, we award the player with an extra life. So let's write that. Game points greater than 200. After the expression, we create a code block in which we have space to write code that only executes if the expression evaluates to true. A code block is simply a block of space between these two curly braces, and code is said to be in scope of that code block if it exists within the braces. In our code block, let's print something out onto the console to let our player know that they have an extra life. You call print and write any string you want to print out inside the parentheses. So let's say you have an extra life. And let's go ahead and run this. And we see that because this holds true, we get our print statement of you have an extra life. Let's set up another example and see how this can be further expanded on. So going back to our Spotify example, let's say we have a variable called loop on, and let's say that that's set to false. Once again, let's create an if statement to check and do things according to our loop on variable. So if loop on equals true, well then let's print out let's keep listening. And then we can run this. But because this evaluates to false, nothing happens. Now you can go ahead and write this new statement to do things if an if statement fails. And this is called an else statement. So if it's true, then let's do this. Else, print stop listening. And we can run this. Now, because of our else statement, it defaults to the else code block and does whatever's inside of it. So it's not checking to see if it's false, it's merely checking that this has failed. Okay? So it goes, okay, well, the first condition checked to see if it was true, and that failed. The else statement goes, okay, well, then it's my turn now, and then it prints out what this is. We don't solely have to use something as binary as if else, but we can expand on it if we need to. So let's say we have another variable, and let's call this temp for temperature, and let's say it's 70 degrees. Well, then we can write an if statement. If temp is greater than 80, then we can print out it sure is hot. And then we can say else, but if we want like another if statement in between 80 and just a default else, we can say else if temperature is exactly 70, we can print out this is perfect. And then we can compound that with an else, which will print out to let's say it's less than perfect. Okay, so it's going to execute from the top to the bottom, and it's going to check, okay, is temperature at this point greater than 80? Well, it's not, so this will be skipped. Then it's going to default to the else, but because there's another if, it won't just immediately do whatever's there. It will make the check and see if this evaluates to true, and in this case it will. So it will print this out, and then it will skip over the else and go to line 26. And we can see that. So here on, let's say 26, we will print the end. And let's run this over here. And you will see that this is perfect is the only one of these three statements that executes. And then 26 executes regardless of what the results are of this whole if, else, if, else statement. This is the way how we can control for multiple outputs. It is important to know that when we write else, the idea behind it is that we want only one of these things to execute, which is different from something that's written underneath the whole statement, which will always execute, such as line 26, regardless of whatever executes, if not line 19, or rather line 20, or 22, or 24 executes, 26 will always execute, right? So let's say that we made this 65. We will see now that line 24 executes and 26 will still run. This is because 26 is out of scope of the if, else, if, else statement, right? This is in scope of the if statement when we're talking about scope to review. This is in scope of the if statement. This is in scope of the else if, and this is in scope of the else. And if you need to check why, again, it's just within the code block, which is just the curly braces. Let's imagine you have something a little more complex though. Let's say you have something like a game where you have keys collected and you say you have 4 keys. And then let's say bonus token, and that's simply a true or false, whether in this level you've gotten the bonus token. So let's say that's true. So now you're at the end of the level and you need to make some checks. Let's say we have if keys collected is equal to 4, well then you've completed the level. So let's write print level complete. Okay. And then else print out you need more keys. Great. Now this is great and it handles the keys collected. But at the end of the level, you also want to make sure that the bonus token was collected to do something according. So let's go inside the scope of the if statement and we will write if bonus token is equal to true. Well then print go to bonus stage. Else we can write print no bonus. And looking at what we have here, what do we expect in our console? Well, if we run this, we will see that we get our level complete because it goes and checks to see if we have 4 keys collected, and we do. So it enters this scope. It does line 32 of printing out level complete. Then it sees that on line 33, we have another check. So it sees that the bonus token is equal to true. And so it prints out go to bonus stage. And since this is an else statement, it skips that altogether. Then it ends and it sees, oh wait, another else statement from the first if check that we did. But since the since the if executed, the else is ignored. And we're back to line 41. And we can do the check here by saying end of program. And let's run this. And we see that the end of program runs. Again, because 41 is out of scope of the entire thing, it's going to run regardless of what's happening between line 31 and line 40. And we can manipulate this to see what kind of different examples we get. So let's say we get 3. And let's say this is false. What do you expect to print out from 31 to 41? Well, let's run and see. We get you need more keys. You might have thought that we were going to get our no bonus, but we will see why that doesn't execute. So we start at line 31, and we see that our if statement gets evaluated. It turns out we have 3, so this turns out to be false. And it does not go inside, so we never hit this no bonus check. It essentially skips the whole thing from here to here and just directly goes to our if statement. Our else statement, and goes, okay, what's in here? We have our you need more keys print statement. It executes that. And then there's line 41, which is out of the whole thing and just executes end of program. So this is something you need to keep in mind when we nest. And this is called nesting when you put in things inside of each other. When you nest if statements, do keep in mind that if you do need this no bonus to print out, that might not print out at all if you have it inside an if statement that's going to be false and then skipped altogether. Something to always keep in mind. Lastly, let's look at something called a ternary operator or conditional operator, ternary if, inline if. It goes by many names. Essentially, it's a shorthand way of writing an if-else statement. When you have something like the loop on statement that we had before. So let's use that and rewrite it as a ternary operator. So it starts off with whatever the expression that you're trying to do. So loop on equals to true. Then it's followed by a question mark. And then you will write the result of what happens if this is actually true. Let's say print, keep listening. And then you follow that up with a colon. And you write out what happens if this is false. So print, stop listening. The way you can think about it is it follows an A question mark B colon C structure. Essentially, if A is true, then do B, else do C. And if we run this, we need to make this a comment. This is why it's important to do comments. If we run this, we get stop listening because it figures out, okay, this is not true. So we avoid this, and then we do the else statement. And this is a simple way of writing an if-else statement all in one line. Do keep in mind that the disadvantage of this is that this is a little harder to read due to the fact that you have the symbols, whereas the other ones are a little simpler to get across what you're trying to do, right? If one thing, else do another thing, so on and so forth. So there is a trade-off in readability, but if it's simple enough, then it's worth writing like this. One thing to know is that I have been checking a Boolean as equal to true, but if I'm merely checking to see if it's true to begin with, I can take this away, and this also works. Essentially, this is a bool, so it reads it as a bool, which can only be true and false, which is the requirement of the expression. So essentially, this is a way of writing if it's true without having to write out the whole equals true. It just checks the bool and see what it is, right? And in this case, the bool is false, as you see up here. So it bypasses that need for that equals true, since logically it means, okay, it's either true or false, and it could just read it as is. A shortcut that you can keep in mind to minimize the code that you write. Stay tuned for part 2 of control flow, where we will see another tool that we can use for situations that have multiple outputs beyond just the if-else statement and making it a little cleaner to read.